So imagine this. You've just come back home from a long day at work. It's late in the afternoon, and you just want to take a nap. Unfortunately, you live in a big city, and you're right next to a busy road. So all you hear is this.
Keep going.
Go on.
Chase, see if the sound is on. See if the sound is on.
There you go.
Even
Yeah,
better.
that makes sense. I got you.
Is the sound on?
So it's hard to keep peace and quiet. This is why we need soundproofing materials. So my name is Chase Watson from Cousino High School.
I'm Riley Mabuhay. I am also from High School.
And this is our experiment on comparing the foam, fabric, and cork soundproofing materials when used as soundproofing insulation. So why does soundproofing matter? Well, according to the Environmental Protection Agency, soundproofing poses many health risks, such as stress-related illnesses, high blood pressure, speech interference, hearing loss, sleep disruption, and lost productivity.
Now then, before we get into the real meat of our experiment, we feel that you should know some background information. First things first, what exactly is sound? Well, sound is a wave composed of high air pressure and low air pressure that is caused when an object vibrates in a medium such as air.
So when a sound hits a material, three things will happen. One, part of the sound is reflected, another part of the sound is transmitted, and finally, a part of the sound is absorbed into the material. The way acoustic soundproofing panels work is that they try to maximize the amount of sound absorbed into the material to reduce the total sound intensity of the sound.
Now, let's go into the problem we were trying to solve with this experiment and what we hypothesized would happen during it. Our problem was to determine which material out of foam, fabric, and cork would reduce sound intensity the most when used between two panels of drywall. And we hypothesized that foam would yield the greatest reduction of sound intensity when used in this way between two panels of drywall.
So let's go over the materials used in this experiment and the testing procedure we used. So in our experiment, we used 3 different types of 12 by 12 inch acoustic soundproofing panels. This included fabric panels, cork panels, and foam panels. We also used 2 13 3/4 inch by 10 1/4 inch drywall panels. Finally, some other equipment we used were a decibel meter to measure the sound intensity before and after adding the soundproofing material, a LabQuest Mini to connect the decibel meter to a laptop and analyze the graphs of the data, and a phone speaker that's capable of playing a constant pitch of A4 or 440 Hertz.
And here's a picture of our experimental setup. On one end, we have the decibel meter. On the other end, we have the speaker playing the constant tone of 440 Hertz. And in between them, we have the pieces of drywall and the material in between them. During trials, the top of the box was sealed off to ensure that the sound stayed within the box and didn't go out into the rest of the room that we were in. During trials, when the sound was playing, we would insert the panel just like this.
And here's a graph of a fabric panel trial. As you can see, the sound level stabilized at a certain decibel level before adding the soundproofing material. Then when we shifted around the panel to insert it, a peak was caused because of the movement. And then after adding the soundproofing panel, the sound would slowly stabilize to another lower decibel level. We would then find the average of the first stabilization before adding the soundproofing panel, and then we find the average of the second soundproofing stabilization. In the middle, we just ignored the peak because it was not useful for our data. So let's go over our data and data analysis. As you can see by the dot plot, the foam and fabric, the foam and cork distributions were quite right-shifted, but the fabric distribution was approximately normal. You can also see that the foam distribution stretched it much lower compared to the fabric or cork distributions. That can also be further shown by our box plot, which shows that foam is much lower than the other two soundproofing materials. You can also see that there is quite a bit of overlap between fabric and cork. So we aren't really able to determine from this box plot which is the better performing material between fabric and cork. We can only outrule foam. Because even though the box plot suggests that fabric is the higher performing material, cork seems to have an outlier that's even higher than any of the fabric materials, which suggests that that one may perform better. So there's a chance that the data collected by this experiment was entirely by chance.
In order to truly test if there was the difference between all three of these materials, an analysis of variance, or ANOVA test, was conducted. This test checks two different hypotheses, a null and alternative hypothesis. The null hypothesis states that all of the mean sound intensity reductions are exactly the same. And then the alternative is that they are not all equal, which means if even one of the means is different from the others, there will be evidence to reject the null hypothesis. But before doing an ANOVA test, there are certain conditions that must be fulfilled. We have the random sample, which means there's a random sampling from the population, the large sample or normality condition, which states that there must be 30 trials of all the materials, or all of them show no outliers or extreme skewness or like lopsidedness. And then the last one is similar standard deviations, which state that for each of the materials, all the standard deviations must be equal. However, it is hard to know that, and so the rule of thumb for this is the largest standard deviation cannot be more than twice your smallest standard deviation. Looking at this table, we can show that we have fulfilled these conditions. We took a random sample of all the materials. Each of these samples had 30 trials in them, which fulfills the large counts condition, and the largest standard deviation, which is cork, at 2.1, is less than double the lowest at foam, which is 1.25, double to 2.5. And here are the results from our experiment. As you can see,
our very high F value resulted in a very low P value, which meant that there was very little probability that we observed these values just by chance, assuming that all of the means of the three materials were the same.
Now then, just because we got a low value on our ANOVA test, that doesn't tell us a lot. We just know that at least one of these means is different. And looking at the box plot, foam is the lowest. However, fabric and cork, we can't really tell. The box plots have a lot of overlap, and so we would need to compare them separately.
To do this, we can use a two-sample t-test. So in our two-sample t-test, we have two hypotheses. Our H0 means that the true mean of the sound intensity reduced by fabric is equal to the true mean of the sound intensity of the reduced by the cork. And our alternative hypothesis says that the means of fabric and cork are not equal. Conditions for the two-sample t-test are very similar to the ANOVA, such as the random sample stating that there must be at least a random sample from each population. It was fulfilled by our ANOVA test, and it carries on to our two-sample t-test, as well as the large sample normality. As you can see by the graph shown earlier during the ANOVA test, the fabric and cork sample sizes were above 30. The results of the t-test resulted in a t-value of about 1 and a p-value of about 1/3, meaning that there was about a 1 1/3 probability that we observed these values by chance, and there is not enough convincing evidence to state that the mean between the fabric and cork distributions are not the same. So what can we conclude? Earlier, we hypothesized that foam would have yielded the greatest reduction of sound intensity when used in between drywall. However, we can reject this because the data just did not support this. Why was it rejected? Well, the ANOVA test resulted in such a low p-value, and the foam distribution was much lower than the other two distributions. We can rule out that the reason that the ANOVA test was significant was because of the foam distribution. So what happened? Well, when a material is denser, it reduces more sound intensity. For example, sound intensity is inversely proportional to 2 times the density of the medium. Cork and fabric are much denser materials than foam. So therefore, they are going to absorb more sound.
Overall, there were some improvements to be made with this experiment. For example, we could have secured the drywall panels better. When they were being placed in, there was no way to make sure that the panels were flush against the bottom of the box. If they were leaning, that would create a gap for the sound to pass through without going through the drywall and the soundproofing. And there could be better sealing on the box. There were several places where there was a gap between the top of the box, the rest of the box, and the drywall panels, which let sound escape.
Some further research based on our experiment could try varying frequencies or possibly different materials than the ones used in this experiment.
So what do we want to take away from all of this?
So which material was the most efficient? Well, it appears that fabric and cork are about as efficient as each other due to our t-sample t-test showing that there is not a significant difference between the fabric and cork distributions, meaning that they perform about as well as each other.
We would like to acknowledge our physics teacher, Mr. McMillan, and physics teacher McMillan for going over the physics with us and generally helping out with the experiment, and Mrs. Cebulski, our statistics teacher, for teaching us about the statistics method used in this experiment. We're excited. Thank you for watching. Are there any questions?